More than 1 billion kilometers from the Sun, Saturn and its rings dominate the outer solar system. But orbiting this massive planet is a moon that rivals planets in size, Titan. Titan stands apart as the only moon in the solar system known to hold a dense atmosphere. This air is mostly nitrogen, an environment remarkably similar to the air we breathe on Earth. When the Voyager spacecraft flew past in the early 1980s, scientists expected to map its surface. Instead, Voyager's cameras hit a wall. Titan was entirely encased in an impenetrable orange haze. Telescopes and orbital lenses couldn't see through the smog. The ground was totally invisible. To figure out what was hiding underneath, we were going to have to physically drop a machine into the dark. In 1997, NASA and the European Space Agency launched Cassini. Attached to the side of the main orbiter was a much smaller passenger, the Huygens probe, built specifically to survive a plunge into Titan's atmosphere. On January 14, 2005, Huygens detached. For over 2 hours, it fell through the alien clouds, recording atmospheric data all the way down. When the first images from below the cloud deck reached Earth, they revealed a landscape nobody expected. The probe captured branching channels, deep valleys, and what looked remarkably like shorelines. This presented an immediate physical problem. The surface of Titan sits at around -180 degrees Celsius. At that temperature, water is frozen so completely that it behaves like rock. The liquid that carved those riverbeds couldn't possibly be water. We had found a geologically active world that mimics the physical shapes of our own planet, but runs on a completely different chemical engine. Because water ice is solid on Titan, it acts as the moon's bedrock. It forms the mountains and the valley floors. The active liquid is methane. It evaporates into the atmosphere, condenses, and falls as rain. It gathers into streams, cutting river networks through the ice crust, pooling into enormous polar seas. The largest, Kraken Mare, is larger than the Great Lakes combined. It is a fully functioning hydrological cycle. The mechanics are identical to the water cycle on Earth, shifted downward by hundreds of degrees so that methane takes over the work. Nature has taken freezing, toxic compounds and used them to engineer weather systems and shorelines that look completely familiar to us. The surface is only half the equation. If you look back up into the sky, that thick orange haze is actually the byproduct of a massive atmospheric laboratory. Radiation from the Sun and energetic particles from Saturn constantly bombard the upper atmosphere. They break apart simple nitrogen and methane molecules, forcing them to recombine into much heavier, complex carbon-based chains that eventually snow down onto the surface. And if you go in the opposite direction, plunging miles beneath the icy crust, gravity measurements from Cassini suggest you will find a global, pitch-black ocean of liquid water. The solid ice shell between them might not be completely sealed. There could be complex geological interactions, allowing the carbon organics raining down from the sky to slowly mix with the liquid water trapped deep underground. Titan holds 2 distinct chemical environments stacked on top of each other: a methane weather system on the outside and a water ocean on the inside, bringing together the natural solvents and organic materials required for life. This abundant mixture of ingredients allows scientists to study a very specific question: how does random chemistry organize itself into biology? Billions of years ago, before a single living cell existed, the early Earth likely contained a similar rich soup of carbon molecules. Titan preserves a version of those ancient conditions, frozen in deep space. We have no confirmed biological signals from Titan, but we know it has been running a natural, prebiotic chemistry experiment on a planetary scale for billions of years. To read the results of that experiment, NASA is preparing the Dragonfly mission. Because the atmosphere is so dense and the gravity is so low, a nuclear-powered quadcopter is actually the most efficient way to travel. Instead of crawling over a few meters of rock, Dragonfly will fly across the landscape, analyzing chemical samples at dozens of different sites. It might find that the chemistry hits a dead end, and if it finds absolutely zero trace of biology, Discovering exactly where that chemical limit lies is highly valuable scientific data. Returning to Titan allows us to look backward in time. It is an opportunity to uncover the exact planetary conditions that allowed us to exist.